Hello mathematicians, it's Miss Armgart back with another instructional video. Today we're going to learn how to identify when two expressions are equivalent. So first, let's review the MSM simulation. We were looking at this very long expression for the rations that were needed for that treasure hunt. So you'll notice all of the flowers are in yellow. All of the rice is highlighted in blue, and all of the coffee is highlighted in pink. So if you go along and count, well, we have 1, 2, 3, 4, 5, 6, 7, and 8 flowers. So that is where the coefficient of 8 comes from. There are 8 F's in this expression. If you go through, you'll see there are 11 R, and our 2 coffees get combined for 2 C. So when expressions are equal, mathematicians use the word equivalent. You'll see that EQU in equivalent, that is your cue that, equal, equivalent mean the same thing. How can you check and see if expressions are equal? One way we can do that is that we can use substitution. So if we make it really easy on ourselves and we say if A equals 1, are all 3 of these expressions, because there's no equal sign, it's an expression, are all 3 equivalent? Well, let's see with substitution. So for A, we write 1. Use our order of operation to simplify. So 2 times 3, that's a level 2. 3 times 1, that's a level 2. Plus is a level 1. But remember, the whole thing, the parentheses, is a level 4. So we need to do that level 2 inside the parentheses first, which becomes 3. Then we still have in the parentheses a level 1. So we're going to do 3 plus 6, which is 9. Now we can do our final level 2. So 18 is the answer when we substitute in 1 for A. So let's scroll over and check these two. If they don't equal 18, then they are not equivalent. So we are going to substitute in 1. We've got our level 2, our level 4, and our level 1. So the level 4 and the level 2 mean that we're going to do the multiplication. 6 times 1 is 6. 6 plus 6 is 12. It is not an equal expression. However, let's check our second option. So 6 times 1 is 6. 6 plus 12 is 18. They are indeed equal expressions, with 2A times 3A plus 6 and 6A plus 12 are equal. They are equivalent. So here is a new problem. Is 9 times A plus 2 equivalent to 3 times 3A plus 6? Question is going to pop up, solve it, and then you're going to see the solution. If A equals 1, we're going to do the same thing. We are going to substitute. So we are going to rewrite this as 9 times 1 plus 2 and 3 times 3. A becomes 1. The rest of it stays the same. It's still 18. And one step at a time, 3 plus 6, 3 times 3 plus 6 becomes 3 times 9 becomes 18. Yes, these are equal. We solved it using substitution. Now, substitution is not the only way. You can also combine your like terms to prove this exact same thing. I am going to suggest that you simplify, you combine as many like terms as possible before you do the substitution. Substitution is your check step. So we have the exact same. So we know that 9A plus 2 is the same as A plus 2 9 times. So when you add all of these up, you have 9 A's plus you also have 9 2's. We can also use the distributive property. So remember, we are going to distribute. We are going to give the 9 to everybody on the inside. You got to distribute. Now, when you do this, you need to write down exactly each step. So this becomes 9 times A plus 9 times 2. You'll notice we got the exact same expression. We need to simplify further because this becomes 9A plus 18, which is as simple as it gets. You're going to get down to 2 terms because you have a variable and you have a constant. All right, let's do the exact same thing over here with 3 times 3A plus 6. This becomes 3A plus 6 3 times, becomes 3 times 3A plus 3 times 6. Or, again, I can use that distributive property. I can give that 3 to the 3A and to the 6. So this becomes 3 times 3A plus 3 times 6. We can simplify that down to 9A plus 18 is our answer. So in both cases, if you use the distributive property or if you write everything out with that coefficient, you will get to the same answer. Now, the question is, now that we've simplified them, are they equivalent? All right, so first, we look for our coefficients. So, do our coefficients match? Yes, they do. We have a coefficient of 9A, we have a coefficient of 9A. Next, do our constants match? Yes, we have 18 and we have 18. So yes, these are equal or equivalent expressions. All right, folks, we have reached the end of the video. Make sure you have answered all of the questions. Make sure that you have given your example in the notes. And I am Miss Armgart saying happy